All right, so it looks like we're live. So let's jump into this. So Josh here with John, co-founders of Supra. And as we jump into this next webinar, we'd like to talk about, once again, for some of you folks that didn't make it to last week, just what we're doing and what is our point of view. Now, the blockchain problem is, the main blockchain problem that we see is beyond just high throughput, low latency. It also includes the fact that blockchains don't communicate with the outside world. They don't communicate with each other. They don't have on-chain randomness. They also don't have the ability to do automation, decentralized this, then that, right? These are what are called the Oracle problem, and these are functionalities that blockchains normally lack. Now, what we're doing today is we're going to be sharing more about our various protocols, and we're going to talk about our kind of general point of view as to why the modular stack may not be optimized, and that there is alternative architectures that we're bringing to market that can really move the needle and create what we call super dApps. So John, share a little bit more about full vertical integration.
Sure, definitely. And was speaking to different parties recently about our fully vertically integrated stack. And some people explained it like, wow, that's like the biggest infrastructure play ever. Or this is a defining, like Supra is actually in a class of its own with this new kind of vertically integrated structure. But basically, since 6.5 years ago, Josh and I have been building a layer one with native Oracle, native bridging, native automation with multi-VM support. So we've been building this for a long time. Supra started about 3 years ago, a little bit more than 3 years ago. And we've been building from this L1 with these native services from day one. And when DeFi summer came along, we decided that we wanted to first go to market solving the Oracle problem. So I just wanted to outline that really quickly for the people that haven't seen our previous talks. But what Supra is building and why this is really important is a L1, vertical integrated L1 with native oracles, native automation, and native bridging.
Constant communication, and even I just want to mention verifiable compute. This is
That's
part
right.
of the Oracle problem. Yeah.
And something called VRF, or random, basically giving randomness to power on-chain gaming. And we're really excited about the future of on-chain gaming and just Web3 gaming in general. This vision, and Josh can go through why this is important, but essentially, when you vertically integrate these services, you have lower latency and you have shared security of the L1 itself instead of using all these different networks.
That's right. And also from the developer experience point of view, only one token to manage, not like 5 different tokens, not one for data availability, one for price sheets, one for cross-chain communication, another one for execution and settlement, another one for cross VRF, automation, verifiable compute. But imagine like an application that has to communicate with all these different networks in order to do what you would imagine blockchain should be able to do already, right? So our general thesis is that the iPhone moment of blockchain isn't just data dissemination coupled with a consensus and execution. We think the real blockchain moment is high throughput layer one, multi-VM support, low latency, native price feeds, the same set of nodes doing multiple services. So native price feeds, cross-chain communication, automation, decentralized if this and that, VRF and verifiable compute, and the same set of nodes, and in a manner in which you maintain your security, but your low latency, meaning you're really fast. And our kind of hypothesis, and we're proving this out, is that our solution is faster and it's secure. And the thing about Supra, the reason why we have these webinars, and it's a series, not just one, because actually we have 10 different protocols, half of them which have or will be accepted to top academic venues through these double-blind peer review processes. I would actually claim that at least 1/3 of our protocols, and a couple more come out very soon, are literally the state of the art. So this is really exciting. We're bringing something new to the table that hasn't been done before. And part of this, what we're going to explore today, is our automation service, a decentralized if this, then that, and why blockchains typically don't have this capability. And then after that, we're going to talk about what we think is the future of applications on the blockchains. We call them super dApps. They have super capabilities. They'll have, what we target is like Web 2 type of performance and capabilities, but executed in a decentralized, secure manner, transparent manner. So with that said, with further ado, let's invite Dr. Joshi onto the stage. Dr. Joshi is one of our lead researchers at Supra, one of the lead architects of the DOR protocol, has re-architected DOR to DOR 2.0 even, which we're rolling out in about a week or two. And it's very exciting because we maintain a security while speeding up what we think is the absolute limit in the price feed genre. So without further ado, Dr. Joshi, please jump in and share more about what we're doing with automation and why blockchains don't have this and what this enables. And the stage is yours.
Sure. Thanks, Joshua. Thanks for the kind introduction. Without further ado, let me jump right in the presentation. We have to think about why do we need automation networks in the first place? Now, as Joshua earlier mentioned, that blockchain is a relatively closed system. And that means that when you want to execute a smart contract, it needs an explicit invocation. So that means that you need to send a transaction that I want to call this contract this particular method. And this action has to be very explicit because blockchain on its own does not have the capability to do this. In general, let's say that we have some source environment where some activities are going on and state transitions are going on. And what we are interested in is that whenever I reach in a state where a particular condition is true, I want to trigger an action. And that is the problem that automation network can solve. So what they do is they monitor the source environment for a particular condition becoming true. And once it is true, it triggers an action and calls the target smart contract. As an example, let's say that a user wants to buy Bitcoin if the Bitcoin's price against USD falls below a certain threshold. Now, certainly one way is to constantly the user monitoring it, but certainly it's not desirable, right? So what the automation network can do on behalf of the user is that it can constantly monitor the price feed by oracles of user's choice. And then whenever it detects that the Bitcoin price against USD has fallen below the set threshold, it can say that, okay, you go ahead and purchase the number of Bitcoin that is desired. Another example is for a repetitive task and a time-based task. Let's say that you are a company and what you want to do is at regular interval, you want to disburse salary to the employees. So instead of doing it manually, certainly you can automate it by saying that whenever there is a start of a new month or start of a new week, an automation network can detect this time that a new month has started and can disburse salary on behalf of the employer as per the preset list, how much salary to go for which employee, etc. Right? So in a very general setting, when we think about automation network, the source environment in which the condition becomes true and the action, which is the target environment, could be different. And that's where the cross-chain automation comes into play. Now, for the purpose of this talk, I'm not going to focus on cross-chain automation, but people from our research team have devised very cool solutions to this like Hypernova and Hyperloop. And more details would be available and they'll talk about it later sometime. But in general, you have a source environment which could be the same or different than the target environment in which you want to monitor a particular condition becoming true. And if that condition becomes true in a target environment, you want to execute an action. In general, there could be different kinds of conditions and trigger combinations are possible. Like we have already talked about that whenever there is a price movement in a particular cryptocurrency, let's say that you want to execute a purchase order, or you want to disburse salary at regular intervals whenever a certain time happens. Now, this condition could also be based on blockchain events. For example, you want to adjust your own portfolio whenever if you are tracking an index and the index composition changes, let's say you want to adjust the portfolio. So whenever the index emits that particular event, the portfolio can be automatically adjusted with the help of automation network. And in a very general sense, any programmable condition which is allowed by the corresponding smart contract programming language for that platform, that condition can be used as the condition, and any actionable transactional can be the action that you can perform upon the trigger. So let's take a look at how a typical automation network works. Generally, what happens is that user first has to register its intent that I want to automate a particular task. The way to do that is to register this task in a registry contract. Now, this registry contract can be thought of just as a simple list where every entry in the list specifies that if this is the condition in the source environment, I want to execute this method of this contract, right? So if the condition 1 is true in the source environment, I want to execute contract 1's method 1. Similarly for condition 2, condition 3, and so on and so forth. And typically this part is common across various solutions that are available for the automation network out there, right? Now, once the registration is done, typically what happens is that the automation network nodes sit outside of the blockchain and they have to constantly monitor the state of the blockchain. What they do is that they constantly get the state of the blockchain by monitoring it. So that's the first step, that you get the state of the blockchain. And then it checks that whether a particular condition for the given task, whether it is true or not. Now, typically in a decentralized automation network, it also needs to run a consensus that whether it was indeed the case that in the source environment, the condition was true, because otherwise a malicious node can try to trigger an action, even if the condition wasn't true. This step also could be there in a decentralized automation network. And then once that consensus is achieved, you send a transaction to call the contract. Now, typically, just like any blockchain, when you send a transaction, the transaction sits in a mempool, and it is at the mercy of the mempool that some node will pick up from the mempool and execute it. So these are the typical sort of workflow and steps that is followed by a typical automation network. Now, as you can imagine, that from the moment that you have monitored the state and from the moment at which the transaction got executed, there could be delay of several blocks. And many times, depending upon the criticality of the underlying task, the delay of these blocks could mean missed opportunities, could probably mean loss of several dollars. Right. How is Supra automation different? And we are calling it Supra Platinum automation because we believe that it is notched above. In Supra automation, what we do is that the validator node and the automation nodes are the same. And this is the key insight. And this is also following what Joshua had mentioned about vertical integration, that when you vertically integrate these two things, the SMR and the automation network, you can achieve amazing things. Right? Once they are the same, what they do is that at the end of every block, they just go ahead and execute all the tasks for which the conditions are true. Let me explain in detail. Right? So in comparison to the typical automation network, the step 1 is getting the latest state. But when you're vertically integrated, the first step is not even required because validator nodes are the nodes that are responsible for computing the state. They are not fetching it from anywhere. They are the owners of the state. So they immediately know what the state of the blockchain is. So step 1 gets eliminated. Now, yes, step 2 is there. You certainly need to check that the underlying condition is true in that state. The step 3 is a bit different because there is no separate consensus you are required. As part of committing the block, committing the state, preparing the state commitment, that is what you use and piggyback whatever you do for the automation on top of that. So there is no separate consensus that is required either. Now, step 4, are you sending transaction to call a contract? No, because you are the one. You are the one that makes the blockchain. And that's why that node doesn't have to send it anywhere. It just goes ahead and execute the transaction once it knows that the condition is true. So step 4 and 5 gets eliminated. And then at the end, the state commitment of the entire block is prepared. So that means that at the end of the block, once the regular transaction got executed, and then the corresponding action happened, everything happens in the same block. And that is the concept of zero block delay, right? So let me elaborate further on the zero block delay. So what happens is these are the regular transactions that the block proposer has picked to be part of the block. And once these transactions are executed by the validator set, you are in a state, and this is the state in which you determine that whether the condition for execution of the automation task is true or not. And once it is true, you just go ahead and execute those transactions for which condition is true in the chronological order of registration. Why chronological order? Because you want to prevent concurrence. These transactions, these automation tasks, they are not explicitly added in the block, but they are implicit transactions. The nodes still go ahead and execute it, but they don't appear in the block. But the final state is indeed the result of executing first these set of transactions, which are regular transaction, followed by, in the chronological order of registration, if the condition is true, followed by the transaction of the automation task. And that is the final output state on which the state commitment is prepared and on which the consensus is achieved. So there is no separate consensus for automation either. And this is how the Supra automation achieves a zero block delay. The condition becoming true and action being fired, everything happens in the same block. Now, one can think about several critical use cases that why you want to do this in every block. It probably could be you just immediately want to liquidate certain collaterals if the value of the collateral falls below your safety threshold, or you want to update certain statistics like exponential moving average or time weighted average price, or whether the price is history consistent or not, and things like that. Or you want to adjust the liquidity pool prices. And for all of this, the delay of a few blocks means a huge difference. It can be make or break event. And for several such critical use cases, we can use the zero block delay Supra automation. Thank you very much for listening to this talk. I would invite any questions.
What's really interesting is this notion of the first ever zero block delay automation service, right? And remember, Supra is furthermore vertically integrating Oracle price sheets, almost like basically there's access to our Oracle data block by block. You have access to it, the latest information. And you also have these activities, if they evaluate to be true, like these predicates, time-based triggers or price-based triggers or other various conditions. They evaluate to be true, since the consensus nodes, validator nodes are also the automation nodes, right? They execute it in its zero delay execution, basically. So this is as good as it physically possibly ever could get, as far as we can tell.
Right.
Remember, the status quo otherwise was you have a separate network for Oracle price feeds that are doing Oracle work, a different network that you have your like layer 1 smart contract platform or layer 2, et cetera. But then you have another network for automation services. And the automation network has to be tracking your blockchain. And the communication between one network to another is at least 100, 200 milliseconds, right? So every time you have to, every additional hop between one external network to another, you should tag on at least 130 milliseconds to be fair, because nodes should be distributed around the world. And the speed of light around the world is about 133 milliseconds. So not only is this approach more deterministic, transparent, and also low latency and secure, it's basically gives you best execution possible. And this could be really important in use cases where, hey, missing a couple of blocks can really make a huge difference.
Right.
Rebalancing, liquidations. Yeah, I guess some of the questions that that may happen by the audience, they can go ahead and source them. Otherwise, I do want to ask a couple myself. And that is, from Dr. Joshi, your point of view, what are the challenges in cross-chain automation?
Sure.
And of course,
so this native automation that we talked about, where the source and the target chain is the same chain, right? And that means that the validator node, they immediately know that the condition is true. And by definition, when we say that it's a cross chain, that means that this delay is unavoidable. You can try to optimize some of the delay in the cross chain one. And the second thing is that typically by the time, so this delay is very crucial, right? So in software, there is this very classical in the concurrent program, right? Time to check versus time to execute. Let's say that okay, this condition is true, and we try to trigger something else. What if the condition has become false by then, right? And they introduce certain complexities when there are delays and things like that. And yeah, many times in the cross chain, you have to do a two-phase thing that you put it to the target, you get a confirmation from the target, and then maybe when you unlock some funds from the source, undo if it doesn't result. Because you are really at the mercy of other nodes, right? That whether pick it up from the mempool or not, or how long before that happen. And in fact, another challenge is also the front running, right? So in this setting that we have described, front running is not possible. But if your transaction sits in a mempool, we know that there are possibilities of, yeah, there are some challenges in this different settings. Yeah.
Absolutely. Cross-chain automation is going to unlock very interesting use cases for applications that are multi-chain. However, this will be the haven for MEV and automation extractable value, Oracle extractable value, miner extractable value, Maxwell extractable value. There's different types of, this is also somewhat unavoidable for cross-chain environments because each of the chains have different parameters, they're different algorithms, they're different programming languages, they have different synchrony, asynchrony assumptions, consensus delays, etc. So every chain you interact with is slightly different actually. But this is an area where we hope to also be pioneering to be like provably fair in a cross-chain environment, at least be the best thing possible to handle that. Because otherwise this is going to be rife with, this cross-chain Oracle game with layer ones. That's where a lot of value is going to be sniped from the hunters and such. That's effectively going to be a cost borne by the end user. So this isn't really great. There are types of MEV that are totally fine, but it's this like front running, this toxic MEV in a cross-chain environment. We want to try our best to avoid, ourselves and try to set a good example. And we also think that's what's going to distinguish us, why you should use Supra when you're doing these cross-chain automations and services. Yeah, the other thing to mention here is this should unlock a lot of use cases. There have been many projects that go from one ecosystem to another. Many EVM chain-based projects, EVM projects have started on Ethereum, moved to multiple layer twos, moved to other EVM chains, Avalanche, other ones that are coming up. And now they have little pockets of liquidity across all these different ecosystems. This is a fragmented liquidity, right? Same application, fragmented liquidity. Now, we aspire to be a hub and like a headquarter for that application to also deploy, like on Supra, EVM-based application, great, and use Supra as a command center to rebalance the kind of liquidity and such beyond other chains that you deploy on. We think this is going to be very useful for applications to unify their own fractured liquidity. And having Supra as a middleware ledger in the middle with price feed awareness, cross-chain communication capability, low latency, multi-VM support, automation, right? We think that we can create these conditional transactions that can help the system rebalance itself. So we're very excited about what this unlocks.
So I think, and from what you mentioned, the key insight is that when the different components, they operate in differently, independently, or in a silo, there would always be some information delay or information disparity where there could be either potential exploits lying around, or either there could be certain inefficiencies or missed opportunities. And doing this vertical integration reduces, and for many components, it completely eliminates some of these information delay that we talked about.
So we have one question coming here that's similar to what we just answered. How can this automation be used by any dApp we use on other chains? And so the answer is following. I described that. Suppose you've already deployed to multiple chains, right? You probably have to do some level of adjustment to your application, but by and large, the goal is that you can use Supra as a command center, like a headquarters, to sign transactions from like maybe some sort of master key, which might have to be a threshold signature or a large multi-sig. If you're doing cross-chain, who knows? There's different approaches, right? And I want to make clear, remember, folks, the fact that a bridge is a multi-sig isn't, the issue isn't that it's a multi-sig. I know it's shocking, right? Ethereum is a big multi-sig. A lot of projects that don't aggregate the signatures. Solana is a huge multi-sig, right? They're all multi-sigs mostly. Supra is just threshold signature. We're a little bit different. But the thing is, it's not about the fact that it's a multi-sig in a cross-chain communication protocol. It's how decentralized is it? How many participants are there? What is its Nakamoto coefficient? The technology of a multi-sig doesn't matter. I just want the world to know that and to get that clear, because everyone says, oh, it's a multi-sig. Well, so is Ethereum, so is Solana. What's your problem? It's how decentralized or not that multi-sig is really what this comes down to. Okay, the ultimate goal is that Supra becomes just like the brain. Your applications exist wherever there's liquidity, attention, users, communities that you're engaged with. And that if, for example, if Supra has awareness of your vaults or your positions in different chains and the movement of assets and such, you can automate movement from one like vault to another. Oh, wow, the demand for this asset increased. We sold out most of it. Can we reconcile from other vaults in a way that's cross-chain accounting, completely transparent and correct? But you might want to have some awareness that this is happening in the first place, that there's this imbalance. You might want to have the ability to communicate cross-chain. You might want to have ability to register, the logic. You might want to have the ability to also effectively execute it in a seamless manner. So price feeds, that's oracles. Cross-chain communication, that's a cross-chain bridge automation service to execute the logic in a cross-chain environment is basically why you need to have and types of things that Supra as a vertically integrated infrastructure can unlock. Yeah, with that said, actually, I've been nudged to move to the next segment very soon. But Dr. Joshi, do you have any other questions or comments you'd like to share regarding the automation network?
Yeah, so I would say that this thing was more of an epiphany, right? That basically, hey, you can have a 0 block delay, and then the use cases that you can do when you vertically integrate the Oracle with several other critical applications like liquidity pools, market makers, and things like that. And you do it instantly, right? So this is literally competing for speed with Web 2, right? People say that Web 3 is relatively slower than Web 2, but now we are talking about creating these building blocks and composing them together in a fashion that kind of is getting there on the information transfer and doing actions at the speed of. I think that's where we are heading towards.
Yeah, speaking of which, we know from our internal experiences that these decentralized consensus protocols these days, from a throughput perspective, can beat Visa and MasterCard. You can do 10 Visa and MasterCards on the same infrastructure. It's pretty wild to say that blockchain can outperform stacking 10 Visas together. You know what I mean? That's what we're moving towards. And when it comes to actual value, this is going to be the absolute fastest way to automate value exchange in the world, especially what we're building. You won't get this from Web 2. You can do photos, you can do conversations, you can do that faster than we can in Web 2, perhaps, sure. But if you want to move real value, it's going to be, especially with low latency settlement, with automation in a cross-chain environment. Literally, Supra is going to be the best in the world for this. That's show me if something better is, I don't think it exists. But yeah, so we're really excited about this. We've been working on this for a long time. I've been have the privilege to work with 10 different PhDs. Dr. Joshi has been our research calls at least 3 times a week, several hours, very in-depth, detailed ones, right? And it takes a lot of grinding and creativity to design this. And this will be coming out in the next, it's hard to say exactly the date, but from the theory and the early prototypes and design, we're quite clear. And we're really excited to aim to roll this out within a couple of months post token generation thing even. So in a step-by-step, this introduction of this conditional transaction, you can set, just reiterate here, we can set like, hey, this transaction should only execute if it's only, suppose it's midnight 2025, exactly January 1st, midnight 2025. New year, Bitcoin is over 85,000, Ether is under 5,000. Automatically sells 10% of my SOL and 15% of my AVAX native asset and buy more Ether or something like this. I'm saying that type of condition transaction took into account the time. It also took into account multiple different prices in order to have these set of rules for it to execute my intention. So that's the last thing I want to mention is we think automation network enshrined with our stack is also going to be very useful for bots to execute one's intention and to craft cross-chain automation transactions based off of what your intention is. So you as a human talk to your edge compute Jarvis, say, this is what I'm trying to do. It creates that transaction for you. And if it needs like multi-chain hops and has multiple conditions on it, you just submit it to Supra's registry. And then when those parameters evaluate to be true, we execute it. So this is the future we're moving into, like now, this year, next year, and the year after. Really interesting direction where AI is going to also get, has been getting extremely good, but blockchain technology is getting extremely good as well.